When performing a dilution, we start with an initial solution, often called the stock solution, which has a concentration C initial. And then we take a volume of this initial stock solution, V initial, and then we add solvent to increase that initial volume to a final volume, V final. And then as we add pure solvent, the concentration of the initial solution decreases, giving us a final concentration, C final. And the relationships between the initial and final concentrations, initial and final volumes, are given by this simple equation. We often use the term dilution ratio of 1 to n, and in this, the value of n is the ratio of the final volume to the initial volume, V final divided by V initial. And then using this dilution ratio of n, the final concentration is equal to the initial concentration divided by this dilution ratio. We can now work through the answers to some dilution questions. In this first question, 10 centimeters cubed of stock solution with a concentration 0.026 moles per decimeter cubed was pipetted, and then extra solvent was added to make up that solution to a total volume of 100 centimeters cubed, and we have to calculate the concentration of the final solution. The first thing we have to do is to write down the values of the four variables in our dilution equation. And looking at the question, we can see that the stock solution is given, which is 0.026, and that is moles per decimeter cubed. We're told the volume of the stock solution, V initial, which is 10 centimeters cubed. And we have to calculate the concentration of the final solution, so this is C final, so that is the value we have to calculate. And we're told the volume of the final solution, V final, is 100 centimeters cubed. We now substitute these values in the dilution equation, where CI VI will equal C final times V final. And performing this substitution, we will have 0.026 moles per decimeter cubed multiplied by 10 centimeters cubed will equal C, which is the final concentration that we want to calculate, multiplied by 100 centimeters cubed, the final volume. We have to be careful about what units we're using, but in this equation we have the same units for volume on each side, so we can cancel those units in left and right. We can now reorganize this equation, and we will get that the concentration C, turning this equation round, will equal the 0.026 multiplied by 10, and then taking the 100 across to the other side, i.e. dividing both sides by 100, this will be over 100, and the units for concentration will still be in moles per decimeter cubed. And calculating that, this will give a value of 0.0026 moles per decimeter cubed, which, if we move the decimal point 3 places to the right, will be equal to 2.6 millimoles per decimeter cubed. In the next question, we're told that we have a stock solution with a concentration of 0.2 moles per decimeter cubed, so that is our C initial. And we're told that we want to prepare a solution with a final volume of 100 centimeters cubed, so this is the final volume, 100 centimeters cubed, and that the final volume should have a concentration of 0.010, again moles per decimeter cubed, and that we have to calculate the volume of stock solution. Well, this is the initial volume, V. So now we have the variables for our equation, and we substitute them into the equation. So it's C initial times V initial. So it's 0.200 moles per decimeter cubed times the volume will equal the final concentration, 0.010, again moles per decimeter cubed, times 100 centimeters cubed. Now, looking at the units on both sides of the equation, we see the concentration is given both in moles per decimeter cubed, the same units, so we can cancel those units on either side of the equation, and then rearranging the equation that we have, the volume V will equal 0.010 times 100, and this will be centimeters cubed. Then taking the 0.200 from the left-hand side to the right-hand side, it's a multiplier on the left-hand side. It will become a divisor on the right-hand side, so we can work out the value of this volume, and this will give us a volume of 5, and the units will also be centimeters cubed. In question 3, we're told we have 5 centimeters cubed of a stock solution, so that is the initial volume, and it has a concentration, this is the initial concentration, 0.084 moles per decimeter cubed, and that it was pipetted and made up to a final volume of V. So this, we're told the final volume is a volume V, and that the final concentration was 2.1 millimoles per decimeter cubed. Now, the first thing we note is a difference in units between the initial concentration in moles per decimeter cubed and the final concentration in millimoles. So what we need to do is to convert them into the same units. It doesn't matter whether we make it both moles or both millimoles. I will just choose to convert the initial volume into millimoles. So the initial concentration will be 0.084, but I know that 1 mole is equivalent to 1,000 or 10 to the 3 millimoles. So I can replace the mole here by 10 to the 3 millimoles per decimeter cubed. And by multiplying this by 10 to the 3, we'll move the decimal point 3 places to the right. So this will equal 84 millimoles per decimeter cubed. So now I can put our various variables into our dilution equation. So it's the initial concentration, which will now be 84 millimoles per decimeter cubed, multiplied by the volume 5 centimeters cubed, will equal the final volume, 2.1 millimoles per decimeter cubed, multiplied by the final volume, V. Now we made sure that the concentration units were the same on both sides, millimole per decimeter cubed, so we can cancel those on both sides. So now rearranging this equation, our final volume V will equal the 84 times the 5 in centimeters cubed, and the 2.1, which was a multiplier of V, then becomes a divisor on the other side, and this enables us to calculate the final volume, which will be a value of 200 centimeters cubed. In question 4, we're told that an initial solution was diluted 1 to 200, giving a final concentration of 1.3 micrograms per cubic centimeter. And we're asked to calculate what must have been the concentration of the initial solution. A dilution ratio of 1 to 200 gives us a value of the dilution ratio of 200, and we know that then the final concentration will equal the initial concentration divided by the dilution ratio N. And then if we look at what data we have for this equation, we're told the final concentration. So the final concentration is 1.30 micrograms per centimeter cubed. The initial concentration we have to calculate, so that is C, divided by the dilution ratio of 200. So rearranging this equation, C will then equal 200. It is dividing C on one side and it becomes a multiplier on the other side. So it's 200 multiplied by 1.30 micrograms per centimeter cubed. And this will give a value of 260 micrograms per centimeter cubed, which could be rewritten, moving the decimal point 3 spaces to the left, as 0.260 milligrams per centimeter cubed. In this question, that we're told that a serial dilution involves a number of stages, and each stage, 5 centimeters cubed of an initial solution is made up to 100 centimeters cubed. So we can calculate the dilution ratio N for each stage, and this will be the final volume divided by the initial volume for each stage. So this is 100 divided by 5. This is a dilution ratio of 20 for each stage. And for each stage, the final concentration will equal the initial concentration divided by this ratio of 20. So then if the initial concentration is 0.260, and that is moles per decimeter cubed, after one dilution stage, the concentration would go down by a factor of 20. We'll have to multiply by 1/20. After another dilution stage, it will go down by the same factor again. And then for the third dilution, again, it will decrease by a factor of 1/20. So if we then take this concentration multiplied by 1/20 3 times, we will get to a final value of 3.25 times 10 to the minus 5 moles per decimeter cubed. And then we know that we can change the mole into micromole, because we know that 1 mole is equal to 10 to the 6th micromole per decimeter cubed. And then adding up the powers of 10, 10 to the minus 5 times 10 to the 6 will be 10 to the plus 1, which is just multiplying by 10. So we will have a final value of 3.25 times 10, 32.5 micromoles per decimeter cubed. And this gives us the answers to the 5 dilution questions.